When you go to the pharmacy to get medicine or to the snack bar to eat a hamburger, you don't really think about how those products got there. And when you shop online, how do things get to your house so quickly? To find that out, we came to Ponta Grossa in Parana to Águia Sistemas. But we're not here to see how a distribution center works. It's much better than that. We're going to see how they're manufactured and built. Shall we check it out? We've already been to several big industries, and everything always works really well. It's a bunch of people working together. Everything has its right place. Raw materials going over there, products coming over here. You don't see anyone yelling. Everything is super precise and orderly like a clock. To be efficient, the internal organization has to be really well planned. And this has a name, Intralogistics, which is the set of processes and systems that control the flow of products, services, and information. So in the end, there are two things, kind of like on a computer. The physical part, the hardware that we see, and the software, the system that controls everything. Sistemas not only designs, but also produces and develops the complete automation and storage solution. When I say complete, it's hard to imagine. But look around me. I'm in the newest Amazon warehouse in Brazil. The entire shelving structure, the whole conveyor system was made and implemented by Águia Sistemas. The story starts with an engineering project. It's going to be a warehouse, a storage facility, a factory. Everything is simulated on the computer. From the weight that each column will have to support, to the size of the aisles, whether a person, a cart, or a robot will need to pass through, even the speed and distance of each conveyor is taken into account. The project comes off the drawing board, or rather, off the computer screen, and starts with these steel coils. They weigh about 12 tons each. And there are hundreds of them. They arrive here by truck. And just so you have an idea, usually a truck can carry 4 coils, but you can't just put something huge like that into a machine and start working. Here, there are 2 ways to split the steel. The first is the slitter, elde, which basically unrolls the coil, flattens it, cuts it into smaller strips, and rolls it up again. This is the final result. These are narrower metal coils, with material ready to be worked on in the next stage. If you're curious to know what tool cuts the metal, it's not a super sharp utility knife. It's this right here. A kind of step forms between one roller and the next under a lot of pressure. And that makes the steel tier. The second way to divide it is to produce a flat piece. Then the process is different. It flattens and cuts, but keeps the width. And in the end, we'll have these huge sheets, which are good for laser cutting because they fit perfectly into the machine. What comes out are these pieces, all cut and drilled, but they still need to be bent. The laser is mainly used for pieces with complex cuts and more customized ones. The steel from the narrow coils comes here. The idea is to make the columns, the beams, all the long pieces of the project. The first step is to punch holes with a die. It's basically a press that punches and cuts pieces of metal. This one here, just so you have an idea, is making 42 holes per second. And look how cool the way the leftover pieces from the holes are transported out. There's a conveyor belt with several magnets. That lifts the little pieces and drops them over here. All of this is going to be sold for recycling. And now comes the magical part of it, lead. This metal strip will be gradually shaped. The process is similar to folding paper, except it's with steel. As the metal moves forward, it gets bent more and more. It gets closer to the final product. Here, there are 15 different stages. Each set of rollers gives it a slight bend. It's a continuous process. It's not very easy to see. When it's ready, A blade cuts the piece to the right length. Look how interesting the engineering challenge of this piece is. It's a beam. It's a part that goes horizontally to support weight on top. A sheet arrives, a flat sheet goes in. And in the end, this piece comes out hollow inside without using any welding. The joining of the two ends is done only with folds. And this makes the process faster, simpler. And the piece becomes even stronger, but for that, the production is a bit more complex. Here there are 42 folding stages. At the end of the beam, a piece has to be welded that will serve as a fitting for the structure. And this whole process is done by a robot. It fits the pieces together, takes them to a table, welds them, and brings them back. Here at Amazon, I found the piece being used in practice, Here it is. It's what allows the beam to be attached to the column. The wire meshes which serve as protection or even as the base for the warehouse shelves are also made here. First, the wire is straightened until it forms these really straight bars. Then, the equipment arranges everything half vertically and half horizontally. And at each intersection of the wires, the robot makes a weld. Look at the result. Afterwards, everything goes through powder coating, where the pieces get a layer of powder coating, and then go into the oven. The cool thing about this process is that the finish is really good and very durable. It's the same kind of coating used on bicycles, refrigerators, and stoves, in the end. We're gonna have this right here. There are several different steel profiles, with lots of holes, and that's their secret. The pieces can be put together in many different ways, just like Lego. Guys, made of steel. Everything here is already calculated in the project, allowing you to assemble a full warehouse in just weeks. One thing they do here, which is the ultimate in optimization, is to build warehouses where, instead of columns, the storage shelves themselves serve as the structure. They're called self-supporting because they hold themselves up. So, the same structure supports the products, the walls, and the building's roof. This is a cool challenge because it requires a lot of engineering. It saves steel, transportation, saves time, simplifies things, but at the same time, it requires that the geometry, the design of the pieces, be very well planned. One of the challenges, for example, is making sure the wind doesn't blow the building away when it's empty. This is solved by adding bracing, which are those diagonal metal profiles. And they also build a well-structured foundation, which, besides supporting the weight of the products, also prevents the wind from tearing the structure away. The coolest thing is that each factory has its own needs, and Yes, you on the other side of the screen watching have definitely already bought something that went through a structure produced here. House Show, for example, uses the self-supporting warehouse. It's a factory that needs to store many different products. Panettone, for example, is made long before Christmas. Easter eggs are made long before Easter. Here, in the central kitchen of Madero, they need refrigerators next to where the bread, sauces, and hamburgers are made. There's a huge warehouse 384 square meters and 12 meters high that needs to be completely cooled. And then each type of food has to be kept at the right temperature. So the system has to know what goes where. And the whole process happens almost without any human intervention. The product goes straight from the factory to the warehouse, and from the warehouse to the truck. They're also behind Amazon's new warehouse in Brazil. And it's because of all this super efficient structure that you buy something and it arrives at your house the next day. Warehouses for Mercado Livre, Shopee, and many other distribution centers in the food, pharmaceutical, and cosmetic sectors are also designed, built, and integrated by Águia. At this point, you must be wondering, but what about cargo handling? Isn't that part of Intralogistics? Yes! The entire system of conveyors, sensors, and computers that controls the flow of cargo is also produced by Águia in Ponta Grossa. So now, the next time you go to pick up medicine at the pharmacy or eat a hamburger at a fast food place, you'll remember that for it to get to you, a lot of intralogistics was needed. An entire factory had to be designed, built, automated, and Sistemas takes care of all that.